So it's about the software scalability. Okay, so it's very practical, and I want you to understand what that means, and then what do we do with it with our software or service, and some of the best practices. Okay. Yeah. So these days, whenever you go to the big companies, then besides knowing how to write code, good application, they want to also make sure that you write very efficient code. Okay, good algorithm. That's what they're testing you on the tech interviews. But then after that, another very technical thing that really differentiates junior developer from senior developer is the ability to handle scalability. Okay, so what does that mean? So very simple. It basically means that how your software deals with a large number of traffic or requests. Okay, you build a web application, you build a server, you have different APIs. Okay, and then either you just can handle 10 users, 20 users, or you can do 2,000 users all at the same time. And that has different requirements on your server. Okay, so some of the examples, these are some of the very old data, but at least it shows you the scale some of the big companies trying to have. For Amazon, right? So they need to have the online services to deal with all the orders and browse the item, check the detail, eventually they put in the shopping cart and then make the order, right? So just look at the order number during the Christmas season. That's normally the busiest season for Amazon. Every second they sold 400 items every second. But again, this is some kind of old data. I think right now the data probably is higher than this. But in order to make 400 orders, there's so many people are browsing things, look at the details, compare, and then go back and forth. But every single second, so many orders are being put. Okay, how can you make sure your system's still working all right, pretty fast, and then you shouldn't slow down anything, because otherwise people get impatient. They maybe decide not to make an order, so you're losing money. Okay, so that's Amazon skill. Google obviously has a lot more skills, and more people are searching. Again, these are all very old data, but every day they have billions of searches, and then that goes to every second, do many searches. Think about you're building that server, and then there's so many requests coming in every single second, and that's very different from you're testing something locally just with yourself. Facebook also, they're also very challenging. So they're dealing with all different kind of requests, not just with text, but also images, videos, and also the comments, all these interactions, huge amount. Another one I want to mention is Amazon had a cloud service called S3. It's a simple storage service. And then they're mostly dealing with all the file storage, almost like Google Drive. The reason I'm talking about this one is because this one also got a large scale because every second they have over 1 million requests. But these requests are different because they're dealing with all the files, not just simple search, sending a keywords. It's mostly uploading the file, downloading the file. That actually take a lot of bandwidth. Think about you're building a server. Every second there are millions of requests to download some file from a computer. How could that work? Very difficult, very challenging. Okay, because it's a lot of requirements on the capacity of a computer servers and also the bandwidth. So a lot of the startup companies, if you see the way they grow, normally for the first couple of years, nobody knows about them, not much growth, not many users, they're struggling, they're trying to survive. Once they become successful, once they become famous, and then very often the user is going to grow exponentially. And at that time, well, it's very nice and excited to see the growth. Same time, put a lot of extra requirements and pressure on the tech side to make sure the same services still work. Okay. One of the good examples, I don't know if this example still exists. Every semester when you're trying to, register the course, search for the courses, not sure how the Bronco Direct right now works. Probably better. But when I just joined, students often complain that, during the registration window, it's like frozen or very slow. Is that still the case? Yeah, probably better than before, but it was very, very bad when I was just joined. You know, you see some of the comments people left in Facebook. Uh, it was pretty bad. Especially a lot of people are waiting at midnight to try to join, but then all of a sudden the server crashes, right? So these are all about scalability. Okay, so if you understand this, once you build your application or server, besides knowing all the functionalities okay is working, you also need to know how is scalability. And the way to know that, very simple. We just need to do some load test. Now, hopefully, before the real traffic comes in, you need to have an idea on how good your service is, how many users you can handle. That way, you can start to plan out how many servers you need, all of those. All right, so we need to run some load tests. All right, so this is nothing really new. You know, a lot of industry people do that all the time. And also for another example, if you see the how they manufacture the airplanes. So this is a picture from the Boeing factory. And in Seattle, I don't know, anyone been to that the Boeing tour? If you've ever been to Seattle, you can actually go to that tour. Highly recommend. It's one of the highest rating tours. So Boeing has a very big factory in Seattle, north to Seattle, 30 minutes. And then you can pay for a tour. You can see the real factory that manufacture all this 777, 787, 737, all these airplanes. But then you can see all of this sitting there. And so the engine, normally that's the last part to be installed. It's very expensive and they don't want to destroy them. But as they are assembling all the airplane, they actually put this weight here, just to simulate the engine's weight. So make sure all the structure is okay. They don't have any issue. They don't break, right? So same concept. Okay, we need to do the load test just to make sure that satisfy the requirements. Okay. So how do we do the load test for servers? How do we know how many users we can support at the same time? All right. So there's a tool called JMeter. Okay, so I want to show you that demo very quick. Okay, so this is something you really need to know. Very practical. So basically the idea is that we use software, we use a tool to generate a lot of traffic very quickly. Okay, of course, if you want to test that with 100 users together, you can't find 100 people, 100 computers to do that test. It's too tedious. Using software, we can simulate that, and so that you can watch how the server goes. All right, so let's actually take a look at that one. So JMeter is an open source software, okay? So they got all different versions, and then let's see what is the latest version. All right, so you go here to download it. All right, so that's the software. It's a Java-based software. Okay, you should be able to run the jar file. All right, so that is JMeter. All right, so it's a tool that you can configure some of the requests, the things you want to do, and then you can test that with the server. Okay, so before we do any tests, let's make sure the server is up and running. So I just start one server, right here. So let me see if the server is still running. So go to EC2. Okay, so this is a server, and looks like this is still running. All right, so this one should be running, and then we go home. All right, so looks like this one is still working. Okay, so let me make sure this one also works. Okay, yeah, so this one still works. Okay, so everything is running. It's actually right here. I'm running that with a container. Okay, so what we want to do right now is that since this is a server here, we want to test how many requests the server can handle. Okay, so in order to do that, we need to configure that test. So we go here, there's a test plan. And let's start to add, first of all, you need to add a thread group. Okay, a thread group basically is a group of threads and that simulates multiple users at the same time. All right, so we do a thread group and just leave it there. So how many number of threads? Let's just do one for now. And you know, just by default. Okay, so you got some kind of a thread group here that can help you to generate the request. And next thing you need to configure is the sampler. So basically, since you're sending a test, so what is the sample test you want to give? And this is the server, so I'm going to send the HTTP request, just like how we do it here. I go here, I do /home.ads. Okay, so that is the HTTP request. So we're going to put all the server name and IP address. Let's copy everything here. So this is the server name and the port number. I'm going to put it separately, 8080. And then the path is that home page. Okay, so this configure the same thing as we are doing here in the browser. Okay, so once you have that, you finish this request sampler. And then another important thing you need to configure is the listeners. Listeners allows you to see the results, see all the tests you send, so that you can watch how they're doing. All right, so here I'm going to choose some of the ones we normally see. Let's do a graph. Yeah, this might be useful. And then let's also do a summary. Yeah, it's also gonna useful. Okay, let's see. And then there's another one. We can see the actual, maybe it's a result tree. Anyway, let's see which one works better. Okay, so these are all different listeners just to show you the results in different ways. So you can watch how the test goes. Okay, to summarize, all right, so thread group, basic group of users, thread started sending requests. And obviously you can send them in multiple requests at the same time because it's thread. This one specifies what kind of a test you want to do. What's the URL, what's the API? And these are the listeners show you the results. Okay, let's see what happens. So I'm going to click on this button here to run it. And then just asks us to save it. All right, so it looks like it's finished. So if you see the summary, okay, so we sent one sample, basically one test only. And average means the latency it takes to finish that request. It takes 110, it should be milliseconds. And then maximum time, because we only did one. And error rate means that there's no error. So meaning that the request was going through. And then the throughput, very important, means every second you can do 9.1 requests. Based on, this number is get based on the time you spend. So for example, every request takes about 110 milliseconds. So every second you can pretty much run 9 or 10 requests. Okay, that's how it works. So you can see that results. But you know, this one is very limited because I only send one test. It doesn't mean anything. What I need to do is I need to send more so that I can see exactly how it goes. So you need to go back to this thread group here. And then we can start to say, okay, I'm gonna do 2 users. And then every user, we're gonna let them to send, instead of 1, they're gonna send 50 requests. And then we want them to do this within 3 seconds. Incrementally send it to the server. So very simple. Once you configure that, well, let's try this again. So we're gonna click on, I'm gonna show here the results. And I'm gonna click on start. All right, so this one takes a little bit of time. As you can see, it's 3 seconds. We send a total of 100 requests. On average, it only takes 16 milliseconds to get the results back. Minimum 14 milliseconds, maximum 52. No errors. Throughput this time is 42 per second. It's bigger than before. And that basically means that previous, because you only send one, we cannot really tell exactly how much you can handle from the server. Now you're sending more, and it looks like you can still do that very well. That's why the throughput right now is higher. Okay, so that's how you start to do the load test. And then you might be wondering, okay, so this one looks really good. Can I do more? Can I do 5 users, 10 users? Can I do 1,000 requests? All of this. So the answer is you have to run it. In the test it, that's the purpose of the load test. Okay, so you basically want to challenge the limit of your server so you understand the maximum. Okay, let's try that. So we are going to go here. I'm going to do 10 users. Within 5 seconds, everyone I want to send, for example, 1,000 requests. That's actually a lot of requests. All right, so coming back to the summary part, let's redo this. Click on the button to run. All right, as you can see, increasing. So 10 users, everyone sending 1,000. All right, the server is still going all right. As you can see, the average still very, very low, the low latency, no errors. And then looks like every second we can even handle almost 500 requests. Okay. Of course, the reason they can do this so fast because that this one here, it doesn't do much. Okay, so this is a very simple, just read. I'm sure it's also being cached. So that's why you can handle this very quickly. All right, but again, let's just follow this one. What you can do is go back here. I'm gonna do something called a infinite. So they're gonna keep sending things. Okay, instead of 10, I mean, I can try 20 users. I want to see really sending a lot of requests, see what happens. Okay, this time I'm going to start, click on start again. And we're very quickly, we're adding up to 20 threads. And then see they're sending a lot of requests right now. And then you start to watch the throughput right now, almost 1,000. And then the time is still very low. So meaning it's really fast. Okay. And here is our server. So it's keep increasing. All right. So as you are watching this, now I have a question. So how do you then decide the maximum load you can handle? Where is the limit? Basically, what I did is I keep increasing the load, adding more threads, adding more requests, and see if we can handle. But the question is, how do you know it will not handle anymore? Yes. So when you start getting errors? Getting errors. Okay, so sometimes if your server is kind of running too slow, you cannot handle that much request anymore. You start to see the request queued there. Okay, and because they gotta wait, and that's gonna sometimes produce some kind of timeout. And if the timeout, it will be errors. So yes, when the servers start to fail, you start to see more kind of error rate. Okay, that's definitely one thing you could see, but not always. Like in this case, we don't see errors, and but then the kind of a throughput kind of stays here. So what does that mean? It increase slowly. Does that mean the server is still okay, or it means anything else? Or maybe the question is, besides looking at the error rate, what else can you see to check if your server is okay? Latency, yeah, very good. So latency right here, very, very low. Oh, wait, but you see the maximum. The maximum latency started to change. Right now, the maximum one is 7.9 seconds. But the average is still very low. So that means there might be some of the requests being queued there. Okay, but the average is still pretty good, and it started to increase a little bit. Okay. So very good. So latency and also the error rate, they're both the symptoms when the server getting to the limit. What else? Especially in this case right now, the latency is good, error rate is good. Does that mean the server is really okay? So what else can you do to check if the server is okay? So all these numbers are the things you see from the user's point of view. It's getting slow, it's not responding, it's responding errors. What about the server itself? When the server is running too high, and what does that mean? That what can we tell from the server side? So this one here, looks like the program is okay, it's running, but can we also analyze anything else? Or at least I want to know, okay, if it's not hitting the limit, how much more potentially we can support. So what are the things you can tell from the server itself? Right. So yes. I'm sorry, say it again. Data overflow. How do we see that? Overriding. Well, that's very specific. Like, but in our case here, it's only reading the page. It doesn't involve too much about writing, interaction with the data. This one right now is simple, just to read only. It's not gonna override anything. Yeah. In other words, when you play games, okay, you got the game that high lot of graphics, and if your computer is not good, if it's hitting limit, then what happens? Yeah. Everything slowed down, right? Kind of frozen. Okay. What does it mean to when your computer started kind of become frozen? Sorry. Is what? Like yeah, but what does it mean in terms of hardware, software, the system? Yeah, what kind of resources? I think it's RAM, right? Yeah, RAM, CPU are getting limit. So that's what we're asking. Okay, because right now you can see we cannot really tell how server are doing. They're getting to some kind of very good threshold. The latency is still good, although we sometimes see some of the long time latency. But I want to know, besides all of this, of course, one thing I can do is try to increase more load. But before you do that, it's also helpful to see how well the machine itself goes. Primarily CPU, because all the requests goes in, you load data, you send a request, you need to run things, run command. Your CPU is the most important metrics to watch. And then also depending on the thing you do, RAM is very important because if it involves too much data, it's going to involve use a lot of RAM. And then the third thing to watch is network, the bandwidth. You see how much data being spent. And then last thing, the hard drive. So it's only the four things. Okay, CPU, RAM, network bandwidth, and also the hard drive. But no matter what, the CPU is always affected by the server because that deals with the request directly. Okay, so what we need to do right now is to see, well, this is running, how well the CPU goes. So how do we watch that? All right, so now I'm in the server. So it looks like this Java process is still running. How do we check CPU? Okay, I showed you in one of the tutorials, okay? There's a command called top. So if you see this one, and that shows here, now this is the process that's being running. This one itself takes about 60% of CPU, 70% of memory, okay? And if you look at the whole system, I think this is also the utilization, total of 40%, and 10% system, 30% idle. Okay, so this really gives you a very good understanding about in terms of the capacity. You know, running at this load, you still have about 30 to 40% of idle CPU. That's really good. Okay. If your CPU is running 50, 60%, that's very good. That's very normal. You do not want your CPU to run about 90%, right? When that goes to 90%, you start to see a lot of things get laggy. Okay. So this one gives you a better understanding of how well your server is right now. So for example, let's see if I start to stopping this, and please watch how this numbers start to change. Okay. So right now, I think you're mainly looking at this one. So I'm going to stop this test. And very quickly. Okay, the CPU is not used anymore, and you don't see that anymore. Okay. So if we start to redo this again, I'm going to try to add more threads. And let's start to run this again. And then you start to see the CPU start to pick up. 20, 30, 40. All right. So the throughput is still 1,000. So keep it running. And so right now you should understand, you can watch both sides, okay? The machine itself and also the matrix here. Like in this case, if I'm actually sending a lot of requests and then the server is still not hitting to the limit, then what does that mean? How does that mean the server really getting to the limit somehow, or means anything else? Okay, so this time is a little bit higher. So 1,200 requests per second. That's actually a lot. Okay, so your server, but of course the request we're testing is very simple. Okay, just a web page load. All right, but you can see also from this example, as I'm increasing this one, I just increased from 20 to 25. That produces a little bit more requests. So just keep in mind that as you do the test, your test server also matters. sometimes you cannot really get to a high limit or high threshold. It's not because your server or your program is not okay. It's actually because this machine here, the machine you use to send the load test, that also should be very powerful. Okay, if your machine cannot generate that many threads, and if your Wi-Fi here, internet here is not very good, that also affects a lot of things. So the load test has a lot of things involved. You need to look at both sides, so you understand where the bottleneck is. But no matter what, the server side always tell you how well the server is doing, potentially how much more we can handle. A lot of these are, it's not like completely linear, but most of the time it's close to linear, okay? So you can kind of estimate the final load, how much you can take. All right. But anyway, so that is how you do the load test, okay? So if you want to see more results, we got to test that with a more complicated API. This one is too simple. Run some database connection, load data, and then do some calculation, processing. You can easily see the CPU goes up very high, very quickly. Okay. So this one we're testing is a very simple page. That's why I don't see too many big changes. All right. But at least you know how to watch both sides. All right. CPU is always the first one to be affected. And then depending on the task you're running, memory, RAM is important. Bandwidth, of course, especially when we're dealing with the file downloads and uploading. That also takes a lot of bandwidth. All right. So that's how you do the load test. All right. And then the question is that let's assume that if I'm hitting here the threshold limit, and right now it's 1,200, and my goal is to support 2,000. What should I do? How can I increase the throughput of my server? Yeah. So yeah, use better machines. Okay, just like your own computer. You're gonna play game, change whatever this GeForce is. Like I see students spending $3,000 to buy a graphics card, right? So that's gonna work. All right. So same thing here. You need to put more money. So make bigger and more powerful machines. That's why in EC2 you can choose all these different configurations, different specs. But at the same time, another way you can do is adding more machines, right? If this one machine we can deal with 1,200 requests per second, and if I'm using 2 machines, then I can double that. And also having multiple machines sometimes prefer because it gives you this redundancy, helps with more availability. Okay, so that's basically a solution. So when you see this is not enough, let's just add more machines and put them together. I'm not going to show that one, but if you have multiple machines, what you can do is you use something called load balancer. Okay, so if you go here, a lot of this cloud service allows you to do that. The load balancer means that once you have multiple servers for your application, when the request coming in, you don't know which one to go because every server has their own address. You cannot let the user to choose which address to go. For example, you go to Amazon.com, they have thousands of machines there. You don't need to know which machine they have. You always go to Amazon.com. And then the way it works is that they have the load balancer that knows how to send your request and redirect it to a certain machine. So eventually every server got a similar load. Okay, so the load balancer is basically a program that running that just simply redistrect the traffic. So that way you can easily attach multiple servers here and depending on how much you need. And the customer don't even need to know that. All right, so this is a solution to handle, okay? Number one, you use more powerful machine, adding more machine, and same time, you need to configure the load balancer so that when the traffic's coming in, then you can handle them correctly. That's basically how industry is dealing with that. Okay, for the startups, when you start to see the users start to grow, instead of writing a new program, the first thing you need to do is make sure the service is enough. Okay, and then for big companies, before they launch anything, they need to run a load test because, for example, Amazon, they know every day they got 1 million users using this one. You better actually make sure that are the worst instead of going there and having things broken. So, very practical technique. Okay, any questions? So if you understand this whole idea, okay, so running load tests and then scale the machine, adding machine and putting the load balancer, not too difficult, but again, there are a lot of manual work. Okay, what happened is that, okay, you see the traffic coming in, you see, oh, our server is not running, CPU too high. Let's quickly add another server, configure that with a load balancer, all of this. But that's going to take some time. I didn't demo it, but some clicks and configurations, sometimes, 5-10 minutes later on, your user's already gone. Okay, so that's not a very good impact and experience. So how can we make this whole process simpler and easier, more efficient? Okay, so that's the solution called cloud computing. All right. So we've been using cloud. I already asked you use AWS already, but why there's this cloud computing here? And also, I don't know if you ever saw it, why Amazon has this AWS service that's getting so popular. Why it's not any other companies? Because you should know that for Amazon, that their major primary business was actually on the retail. Okay, so starting from selling books all the way to selling all the other things. However, they are the first company that created this concept. The cloud computing didn't exist before. Amazon created that concept first, back in 2006. And when they launched their first service called Amazon S3, that's the one I mentioned earlier, the file storage. And later on, they added EC2, the one we're using this for this class, and then they started adding a lot more. And right now, they got hundreds of different services. Okay, so then the problem is that a lot of people don't understand. Oh, okay, I saw you guys are selling books stuff. What is this called computing? And you start to explain. Oh yeah, it's a server. It's very convenient, very quick. You can configure things you want. But then people started having thought. Are you sure? You guys just a e-commerce company. You guys can deal with server. I probably would better to trust Google to do the server stuff. Right? It doesn't sound like you're a very strong technical internet company. That of course, right now when you look at Amazon, you probably feel it differently. But you have to say like 10 years ago, 15 years ago, it wasn't like this. And we more prefer to see Microsoft or Google to be the tech leader to actually create this kind of technology. All right, but it was Amazon. Okay, so I want you to understand that this whole story and history, it was very, very expected that happens for Amazon. And Amazon really got this very good opportunity, and then they create this new thing that becomes really good. And then in fact, this whole cloud computing service or business for Amazon is so important today. If one day you don't see the retail exists anymore, don't be surprised. And it just means that they're doing a lot better on the cloud computing side. Okay, so a little bit of background of Amazon. You need to understand this one. Very interesting. So they were all doing the retail sales and think about, I think this is a homepage around 2007 to 2010. You guys probably don't remember. I still remember that a lot because I was using that, and also I did an internship. So that was the old page. Okay. So I already explained, a lot of people are using that. That's basically the largest one in the US, and nobody else can compete with them. So they got a lot of traffic. Every second you can imagine people are searching, they're clicking on the product, seeing the items, the details, and make orders and doing all different things. A huge amount of requests. So for them, the load very important. And then they got a lot of people. They do a lot of analysis. So they understand how and when the users are coming in, and which is the peak time. So this graph, pay attention. Okay, so this is how the Amazon is receiving their traffic every day, very standard. And this is also a very typical traffic pattern for most of the internet companies. So 7 days a week, every day you can see there's some peaks. And then basically these are during the daytime. One of the peak time is around noon time. Another peak time is around evening time. That's when normally people having break and spending time online. Something interesting you can see, the highest peak happens on Monday, Tuesday, Wednesday, not actually on Friday, Saturday, Sunday. Okay. Well, because on the weekend people all go to play and they don't spend all the time on the internet, or at least browse Amazon to buy things. When you come back to work and then you just don't do work and then you spend your work time to do all that Amazon stuff. All right. Also see the peak time is during the daytime, okay, not the evening time. Also shows that a lot of people are just doing all random things at work. Okay. So, but this is a real pattern. Okay. So anyway, so if you see the pattern, pretty good. So if you're an engineer, right, you need to start a plan and do the test. Make sure your load is okay, your service is enough. So you do the test. Your goal should be the peak time, right? You want to make sure that you can support this peak time. It doesn't matter about the early morning time. You need to make sure you support everyone. Okay, make sure the server is at this level. So that's what they do. So they run a lot of tests. They want to make sure that they can reach the load, not just the peak, but something extra. So that way, just in case something happens, something unexpected, that normally happens. They got a deal, they got a promotion, sometimes they got hacked, all of these things happen. You can see some of the abnormal traffic. So getting some buffers here, that helps. Okay. So they basically run a lot of tests and adding server until they see they can get to this level. And then they're good to go. All right. So if you understand this, there's slightly a problem, okay? The problem is this. You are planning a server that runs at this high, so support that kind of a load, but you are not really using this all the time. For the peak time, I get it. Okay, you want a buffer, you want some safer, space, so you plan extra. But during the early morning time, it wasn't a lot of traffic. You're still planning a lot of this. So the server is basically all running there, just like our server right now. It's not really using a lot, 40%, 50%, a lot of idle CPUs here. It's kind of waste. Right? But you might be saying, okay, that's fine. If I got that much traffic to use my site, I don't worry about that waste. Okay, it's just some servers and machines, not a big deal, right? At early morning time, yes, not many people are using it, but it makes me sleep, more comfortable. Okay, I don't need to worry if my server is broken. Okay, so I like to put that money, not a big deal. For Amazon, they made a lot of money. They don't worry about this service. All right. Besides, you're using still 60% of your machines. Not bad. Only 40% are waste. Right? So every year, Amazon business grows, they start adding more server, but that's okay. 60% of the servers are used, 40% for safety, availability, redundancy, worth it. Okay, so that's not a big problem, even though it's a small waste. But the big problem happens at here. So look at this graph, similar graph, but this is the graph for the whole month of November for Amazon. Okay, now for November, obviously the last week is a very special week. It's a Black Friday, and that's what basically their business period of time for the whole year. For the entire Q4, Christmas, Thanksgiving, it's really, really busy. And Thanksgiving obviously is the busiest. Nowadays, not sure how much you value Black Friday, but at least 10 years ago when I was in grad school, yeah, that's a big deal. Okay, Really big deal. Everyone's waiting and on that day to do things. So if you look at the traffic, for the Black Friday traffic, this peak is so much higher than the normal days. Even during the weekday, during the even like daytime or early morning time, that's still very, very high. And sometimes double, triple. Not surprising. Right? So when you have this kind of pattern, well, you're the engineer to do the load test. Of course, you still want to make sure that you can handle that kind of peak traffic. It doesn't matter because at that Black Friday, you need to make sure everyone can make their orders quickly. Otherwise, you're going to lose a lot of money. You must do that. So this is still how they're planning the server for that month. Make sure all the servers are ready. I can handle that one day, one night. Okay, so nothing wrong with it. Okay, you're doing your best, but the width had been changed. Previously, you were using 60% server and wasting only 40%. Right now, it's opposite. You're wasting 76%, and you're only using 25%, 1/4. All right. And you might think, okay, that's fine. Black Friday, it's worth it. But the things are not that simple because once you put that much server, you basically bought the server. Okay, you can't return them. You need to have warehouse data center. You need to have people managing it. It's basically the cost sitting there all year long. And it is a cost. When this is small, you don't feel it. But when you get to Amazon this scale, if you're not using like 75% of server, I mean, think about how much money you put on the warehouse. Basically, you're building this big giant warehouse. You're only using 1/4 of it. And majority of them are really not needed, but you have to support them all the time. And that cost forces Amazon to start to think about it, and they cannot reduce it anymore because Amazon is always running in a very low margin business. So they're not making too much money per order, but they make money by volume. The traffic is huge. So if you look at their financial report statements every quarter, it's quite different. If you look at Google, it's a high margin. Google makes tons of money. Okay, so there you think because the way the Google make money, you click on something, they make $2 or $3. For Amazon to make $2 or $3, how hard? Okay, you got to package them, you got to people to shipping it, all this work there. It's so difficult. So that's why Google has a very good business. So for Amazon, they got to deal with this. All right, so then they start to think about, okay, what should we do with this? Since we have to plan this, spend this anyway. Well, so the motivation come from themselves. Okay, so that's how they start to create this new business model so that they can better utilize this part of the resources. And the business model is very simple. One is that let's just rent it. Okay, so since we're not needing it, someone else might need it. We have so many more servers. Just come here, we'll run it for you, and so that you can we can make some money and we can sell it cheaper. But then they saw that server renting isn't a new business. How can they make it more attractive? How can they make it more special? So Amazon created a very cool idea that totally based on the demand, and then turn that into some kind of utility kind of model, like the water, electricity. You only pay when you're using it. Okay, so that was a very big innovation. So that's why when you use EC2 right now, it's all charged by hours. Okay, so they came out with this kind of utility model that you can just run our server by hour. Okay, so if you only want to run very intensive program or task, you're done, you don't need it, just stop it. Stop instance, we're not going to charge it anymore. That's how they can attract so many people to start to do that service. Because if you start to look at the pricing, it's really, really cheap per hour. Okay, so that's one thing. They rent their resources, and so that people they don't need to worry about the actual cost, and they can start to resell this resources and then make some extra money. The second motivation is that for the changes, okay? Because this, let me see, I'm missing some kind of graphs, okay? Yeah. The second motivation was that previously we're doing this kind of a load testing and planning based on the peak time. Okay, this works, but it's not the most optimized. Is it possible that we just do the actual allocation? If you need that much, I'll give you that much. Maybe a little bit extra, but not this too much. During the early morning when nobody's using, can we reduce the servers to only support that much more? Because if you can do that, and then you can really allocate the exact resources you need, and then you can get all the extras for other purposes. Okay, so that's another motivation for Amazon, right? So that's how they come with this thing called auto scaling. So you already understand, you see the traffic coming up, CPU high, add server, add more server, change bigger server, balance, load balance them. Okay, the practice is there, but I explained that you need to do this manually. So Amazon had this auto scaling service that you can configure, and you can put a policy to say, whenever the CPU goes over 75%, please add another server. Okay. And if the CPU is still high, add another server until it drops below 75%. So that's called auto scaling. So you can do this very easily in EC2. And you can also configure another policy to say, if the CPU utilization is below 30%, reduce one server until it comes between 70 to 70%. And then you remain the server free. So that's called auto scaling. So really change and control the server size based on what you need. So that's the two things they did. Number one, run the server with the utility model. Number two, auto scaling. With this concept, they kind of formed this new model called cloud computing. Even though you look at cloud computing, you still feel, okay, so it's just basically running the server. Idea is the same, but some of the details are totally different. Okay, because first of all, the auto scaling, okay, adding server, it sounds simple, but it's not. So they have to be able to provide this kind of virtual environment that you can quickly add a server within a minute. Okay, it's not like in the past, you had to order the server, they set it up for you, and wait for everything. It takes days and sometimes weeks. But now they create a server for you within a minute. That's how you can do auto scaling. And because they can create a server, release the server so quickly, they can enable this kind of a utility model. Also almost like turning on and off your light. Start instance and stop instance. So the model looks simple, but the implementing this whole model isn't. That's why I call computing is a very big deal. All right. So probably I think around 2010, 2011, for Amazon, they start run their Amazon.com all in EC2. Previously it was not. Previously, they were doing that in their own servers. That's what I showed you. They have own servers, and EC2 are the actual resources they don't need. So they rebranded into a service. And then once they figure out the EC2, everything is going all right. So they start to run everything under EC2. And so 10 years ago, I remember they were using 5,000 large servers to support Amazon.com. Right now, probably the servers are much more than that. All right. So as I mentioned, for cloud computing, based on some of the very important techniques, virtualization is one. So that's why you create an EC2. You got a CPU memory. It's not a physical. Okay, they have a big machine that they split that into smaller ones, and then you're running yours in one of them. When you do these things virtually, it's faster. Okay, it's basically like software. It's like Docker. If you run a Docker, you got OS very fast. So virtualization is important to support cloud computing. Very flexible. Okay, you got different options based on what you need. So you only pay whatever you need. So very cost effective. It's really fast. Okay. This, you need to understand how the old days people handle with the server. Again, you buy an older server, set up internet, and install all the software, configure the port, and you might need to hire a system admin or a network admin. It takes months to start running the server. But in EC2, again, it's under 1 minute. And also, you don't need to worry about the availability because you can easily create multiple ones. But if you're setting your own home server room, anything is broken, you're done. Okay, you got to fix the machine, change the machine, fix the network. But Amazon, you can easily create many. You can create many in different kind of parts of the world and different data centers, so lower the risk. Okay. Also, you need to understand the cloud computing model is really good for startups. Okay, because think about for the past, if you were doing a startup company, you need to buy the server, set up everything, you had to put that money anyway, even though you don't know if your server, your startup can survive or not. But now, day one, you're building your startup, you don't know how many users there will be. That's okay. We will just run a small server, use a micro server, free tier, just start running. You know there are not many people are visiting your site. And then later on, you got successful, you see more users, and then we can start to increase the server. You start to pay more, but it's worth it because you got more users. Okay, that's why there's no setup cost for cloud computing. Every startup basically starting with AWS. You almost don't see anyone who's still buying a server until you get really big. Okay, you got a really big like a Dropbox. Okay, they need so much server, they pay Amazon so much money. They realize, well, I need to build my own data center. That's okay, but to start a business, cloud computing really gave you the best option. Okay, auto scaling is a very big deal, and also as you can see, the startup makes things very, the cloud makes the startup server stuff very simple to do. So lower the bar. So as a developer, you do not need to worry too much about all this operations, the server stuff. You just need to focus on the application itself, which is more important to your business. Okay. So as I mentioned, all the startup they all start from like cloud computing. All right. Yeah. So anyway, I'm just gonna stop here. Okay. So these are the major benefits about using cloud computing, but you need to understand that the reason that cloud computing came up is because of the scalability issue, and that's why Amazon is perfect sense for Amazon to deal with this. Okay. Now, Google didn't do this one because Google didn't have the motivation. Well, first of all, they made a lot of money. They don't really care. They don't care too much about the server. Secondly, for Google, they don't have this Black Friday thing. Every day they got a very high traffic, so it never an issue for them. They just need to maintain that very high server. Microsoft, they don't do a lot of server stuff. That's why they don't have the motivation. So it makes perfect sense for Amazon to do this. So that's why Amazon is doing really well in this kind of innovation. Okay, they figure out something, they start to realize how can they expose the service to benefit others, to sell it, and they're really good at this. Okay, so later on, a lot of things you see are actually internally from Amazon, based on their needs. Okay. All right. So anyway, so scalability, again, you don't feel this too much as a student. Once you join company, most of these, especially big companies, okay, all the code you write, all the things you do, you always think about, does this one work with whatever the user you're dealing with. Okay. So that really shows your experience. Okay. So any questions? All right, sounds good, guys. Okay, I'm gonna stop here, and then next week I will probably start to talk about some of the interview stuff.